Hey there. I've been waiting. Do you see the time here? That's how long it took that video to process. So I started uploading another one, see if that might, have any effect in making this stuff complete its processing. 14 minutes. Can't be smaller than that. It's quite short, which was another thing that should have surprised me. That such a short one would take so long. Anyway, the title of this one, would look something like this, which probably sounds like a pretty boring topic, just the definitions of these words. But in my pursuit in finding definitions to these words, I have again changed my mind about this whole major Allen and minor Allen business once again. But the changing of my mind came about through scrutinizing the words and trying to find out exactly what is being referred to. These are the sources for the words that I've been using. One, local help file. The helpful help, the HHF helpful hint file, and the first word that I've been most curious about, and which is used all over the place, is this word session, for instance. This is me. This is the logged on user running this program. The logged on user is also the one clicking around. That would be what we used to call minor Allen. You'll notice how my session number is growing and growing. Oh, sorry. We're trying to define session. Okay. No, this says session. But there are a whole host of other things called sessions that don't come out to the number 13, and so I must conclude that they don't refer to the same thing. Okay. In the glossary, the security glossary, help. Let's make sure that's the correct one. This is security glossary. So things to do with security, session. I'm going to copy it out of the wrong section. Session. Okay, that's the same one. And a session, according to the help, the hints, is an exchange of messages under the protection of a single piece, and that may be important, of keying material. Now, they don't tell you what keying material is, even within the glossary. I tried to find it. So that's why I had to look elsewhere. There's key container, distribution, key pair. If it's in there, I don't see, well, L is before M, and P is after M. So if keying material were in here under K, and that's all there is for K, it would have to be there. So it's not, definitely not in there. Hence, it is taken for granted that anyone reading this definition already knows what this is. So that means that unlike me, the person reading this is assumed to be somewhat of an expert on security in general. I'm not. I'm trying to at least just understand a particular type of security without, going to going back to university and getting another degree. Anyway, for example, SSL, also undefined, but I've heard that before. SSL sessions use a single key, and again, key on its own was not defined. Only the first is key blow. Under a single key, to send multiple messages back and forth under that key. Okay, so even though this definition uses 1, 2, 3, even 4, because I'm not sure exactly what that means. Even though this definition uses 3 or 4 undefined words, there are enough hints, because this is the helpful hint file, to allow us to infer that whatever a session is, it is something to do with communication messages under an umbrella of protection. Okay, that's the way I would turn that into English, common language English. A session is a unit of conversation under the umbrella of a type of secure, in being protected by something. That is, the messages are. To further probe this definition, I went online and I found an excellent website page or whatever, which contains a glossary of all terms concerned with security. And within there, I found a definition for the noun phrase keying material. And the link is here. Now, there are 2 references cited, and this is the one that they chose. It could be that there are 2 possibilities. One is physical material, and I don't think they're talking about physical material, like magnetic strips and so on. But the second definition, data, such as keys, still unknown, key pairs, and some initialization values needed to establish and maintain a cryptographic security association. And you see how that's sort of in agreement with this. Okay, so therefore, this key here being referred to is the same type of key that is being referred to here, I think, or it could be pairs, but they don't say pairs. So it's probably the first one. And so the keying material is a key, a piece of data required to maintain the cryptographic security association for the exchange of messages. So we know more of that session now. Then I went on to find out if I could find anything about this key. Now, this sounds correct to me. There are various ones to choose from, but this is pretty good. A long string of seemingly random bits used with cryptographic algorithms to create or verify digital signatures and encrypt or decrypt messages and conversations. So in our case it would be the second one, to do a session. The keys must be known or guessed to forge a digital signature. And we're not talking about digital signatures, so or decrypt and encrypted messages. Now, I'm thinking perhaps, for instance, public and private key encryption, RSA encryption. I added this bit at the end. This RSA is something I know a little bit about. RSA encryption, the R, S, and A stand for these three names. Okay, so we got keys, something like RSA keys that are used, and only one, okay, however it's used, establishes a session it enables an exchange of messages under a protection scheme using just one key. And the key is a type of key that has to do with encrypting and decrypting messages. So that's what a session is. Done. And it's close enough. Okay, now in the local help, they do define something called the session key, which I'm assuming is the same kind of keying material being discussed here. I may be wrong. A randomly generated key that is used one time, then discarded. Okay, now if that's the case, it follows simply by logic that this is not a session key, because it is certainly not randomly generated. I can predict exactly what this number will be the next time one is generated from knowing what it is this time. That is, if I log off and log back on again, this number will become 14, and that's not random. So therefore, that is not a session key. And then discard it. Session keys are symmetric. They're used for both encryption and decryption. That agrees with this single piece part. They are sent with the message, protected by encryption, with a public key from the intended recipient. Now, public key it sounds to me like RSA encryption, where there are two keys, one being public, and the public key is used for the purpose of encryption of messages. And then there's a private key that nobody knows about except the people having the conversation, and that part is used for the decryption part. A session key consists of a random number of approximately this many bits. Session keys can be derived from, now here's another thing that you're supposed to know, hash values by calling crypt derived by calling this function. Okay, now I don't know if you know what a hash value is, and I've had my own guesses. I never wrote a hash algorithm or anything on my own. I just used what was provided. Got a general idea of how it works, sort of like the way you might sort things in by alphabetical order or something. But I'm just going to tell you what this says, what the MSDN says for a hash value. Okay, and then I'm going to show you why that definition makes sense. And this part is really kind of irrelevant, but just for curiosity, if you're curious, a hash function is any algorithm, any procedure that maps data of variable length, so like strings, or sentences, to data of fixed length. Okay, now that's basically the definition they've given. The values returned by a hash function are called hash values, hash codes, hash sums, checksums, or just hashes. Now, how in the world does that have anything to do with deriving encryption keys and so on, or in fact with the usual use of these hash values is sorting things, right? Or storing what they call associative arrays, which is like a map, usually a map, which is something where you have what am I doing way over here? For instance, there's in the standard template library, there's a class called map, and it takes like a key value, a key type, and a value type. Okay. Now the key type could be anything. It could be a string, variable length, for instance. And using it is as simple as using an array. Like I have my map. I can say my map something. Suppose I used string for the key equals 36. Okay. So it's like an array where the index is not a number. It could be anything. And one way to implement an associative array is to use a type of hashing algorithm, which would convert these variable length things into something like a number, and thereby simplifying the retrieval. If I want to retrieve my map of this, I don't have to check through the entire English language or every possible combination of letters. There's a way to obtain this value quickly. To that end, I went looking again online, so I guess this is another thing to add to my sources. And wait, let me check my time. And I found this very like for dummies explanation of how hash tables work, which is great. You know, I love those for dummies type things. Because usually the only way is you got to start with the for dummies bit and then go to the details first next, right? And this person's asking, how does a hash table work? In plain English for a simple general, I don't know what. I know it takes a key and calculates a hash and does some modulo something. But that's where my knowledge stops. Actually, that's pretty much where my knowledge stops. Can anyone clarify? As well. Exactly. This is exactly my question. I don't want to know specifically about how it's done. Just how does it? What's the idea behind it? And this is pretty much a perfect explanation. I already think I plussed that. Let me log on to this. Yeah, plus. Oh, I have to have a better reputation. Okay. This is great. So suppose you have a library full of books, okay? One thing you can do is you can just stuff all the books in the library, you know, and be done with it. In fact, that's the way books were pretty much stored up until the 16th century, all throughout the Dark Ages. All these monks were writing these books. But they didn't sort them or anything, they just laid them down, you know. And that one of the difficulties for historians is not so much that there isn't a lot of information available, but there's no way to find anything in it, because it's all just randomly thrown about. Anyway, so you could do that. You could just throw everything in at random, but that's not going to be very good for someone who wants to come and asks for a title of a book, and the only way to find it then would be to start at one end and slowly go through each and every title until you find the one that you want, right? It would be better if you could sort them in some way to speedily retrieve the book. Okay, so here's one way that you could fill up the books in the library. One possible way. One way is, A, B, C, and so on. But here's another possible way. You devise a clever method. You take the title of a book and you run it through a little computer program, and the computer program spits out two numbers. One, a shelf number, and two, a slot on the shelf. And the librarian, when they are to store the book, they simply do exactly what the computer program said. It doesn't matter how that algorithm works. You simply do whatever it says. And the algorithm is designed such that it will always produce the same output as for the same input. Okay? Later on, if somebody comes along and wants to retrieve the book, they tell you the title of the book, run it through the algorithm, and where it had previously told the librarian to store the book would be where you would retrieve it from. So you go there and you get the book instantly. Now what you've done is you've taken a variable length title string and turned it into two numbers, fixed length thing, and used that as the way to store and retrieve books in the library, and provided there aren't any collisions, then you can instantly store and retrieve the books from the library. And that's essentially all there is to hash. Okay, the algorithm part, of course, is the difficulty, right? And he goes on to explain that. I'll include this here so you can look at the more of the details on your own. Just add that to my list of URLs to include. Well, so I'll include these ones. Well, not that. Okay. Now where were we? Oh yeah, hash. So that's it. That's a hash value. Now another thing that was mentioned was session key derivation scheme. Now where did that come from? I looked that up. Oh, because the keys, remember, are being derived from these hashes, right? According to the thing here, keys are derived from hash values, calling this. And I also found, so online, another interesting article to do with session keys and the kinds of schemes that are used in particular for these sessions being discussed. So now that's just a PDF file. Actually, I think I saved it. Where would I put that? So if you want, I can include this. if you want to have a look at an example, this is very much in the on the technical side, okay, and really goes into a lot of detail on how these session keys are derived. If you're of a mathematical inclination or physics, something like that, then you might be able to make sense of some of these things. Okay, you know, they talk about entropy and statistical analysis and you know, probability distribution functions and stuff like that. So if you want to really know a lot about it, then you can go to that. I don't want to know that much detail. All right, so now we know what, at least what a session is. Now I'm going to make a note here, because session comes up, the word session comes up in my PS-Toke program. One, well, this is called a logon ID. So, and in fact, it's an LUID number. There are actually two numbers here: high word, low word, and that has to do with something called the logon identifier. Now, this here looks to me like something that might have been randomly generated. But is it a session key? Don't know yet. The token's originating logon session is what they give for this number. Now, that certainly is not randomly generated. In fact, it's the same number every single time. So this is not a session or a session key. You can be sure of that, at least as far as their definition. The source of the token is an LUID value. Doesn't have to be, in fact, but it happens to be. And in fact, it is this number is provided by this source, it turns out. Okay, that might also have something to do with the session. Now the word session is used in the summary part where they called this the session being represented. Okay, 302. In my list here, 302 is the first number. In the list. And if you recall, when the major and minor Allen discussion was going on, these had different session LUIDs, right? And that made them distinguishable. Okay. There's a thing called terminal services. That's certainly not a session in the way it's been described. And then there's something called a session authentication ID. And that number I control C on that. is the one that I'm printing at the front here. Okay, so that one differs between this process and this process. What doesn't differ are all of the other numbers. The terminal services session indicator, counter, session counter, you could call it, is the same. This second number is called the logon ID. That comes from this FACO SI security identifier. That's this one. Same for both. This third value is also the same, and that's the one that is issued by the source of the token. Okay? According to the help number, aids the source component in relating context blocks such as session control structures and blah 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 to the token. Alright, this is an insert. As long as this video is actually is, and it continues on quite a bit longer, I do I wanted to point something out at this juncture anyway. To do with these three numbers, and the middle one, which we were looking at in the help, which had to do with the source of the token, this number. This number, you can say with certainty, is not a session identifier. It might be locally unique, but as it is explained here, it is not characterized as a session number. That is, it's not used for any purpose of messaging. It's used internally by the source component in relating things that have to do with sessions, right, to the token. In particular, the reason that number is appearing in the middle is because you're always going to find that the number to the left-hand side of this number is always greater than it, and the number to the right always less. So this, I believe this number, okay, provides for the issuer, the source object, sort of a marker, a point, a relative identifier in a sense, right? But I think that the reason that this number has been recorded is, as it says, to be able to determine the relationships between various components. If suppose a session of the authentication identifier number came along and was less than this, right? Then perhaps that component, that number, that fact might indicate that something is going wrong. Right? Maybe they all have to be bigger than this. It's something like that. But in itself, it doesn't identify any session. It's not used for communication. Okay, that's all. Just wanted to point that out. So it's not really for our use. Okay. Now, I just want to get to the key point. Now, can I get there quickly? This is where the major and minor Allen's debate, I believe, comes to an end. When logon session is defined. Okay, we sort of know what session means now. Some kind of secure communication thing. Here's the definition. A logon session begins whenever a user logs on to a computer. All processes in a logon session have the same primary access token. You shall note. Oh, this one is different. This one's access token is not the same as this one's access token, right? For one thing, that number came out different. This number came out different. And for another thing, oops. The owner of this token is not me. It's something else. The owner of this token, could be a coincidence, is myself. Okay? This program is running on behalf of me. This program is not running on my behalf. That is, I'm the logged on user. This is the logged on user. And according to the cell file, so what I printed out from it, all processes in a logon session have the same primary access token. These don't. Okay. Well, let's look at another process in this logon session. Or, sorry, yes, well, whatever, that's around. Now, Dropbox here is a program that runs at startup after I've logged on, and its ID is 2140. Let's see. It happens to have the same privileges as me. Non-impersonation. It's owned by me. Not restricted. This number is the same as everything else. This is 302, same as here. And so, same as me. How about Chrome? I know that I started Chrome by clicking here, and I didn't run Explorer from this box. Where is Chrome? The part of Chrome that is not totally crippled. Something visible. What have I got going here? Well, I could do this notepad. PS toke 1356. Look at that. Only 5 privileges. Authentication ID 302, same as Little Island. See what I'm saying? All of these processes, doesn't matter which one you choose out of this list, except for something possibly executed from this box. How about this one? DX4 4508. See? Another one. But that's true landing yet. How about DWM? I don't think I'm allowed to look at that anymore. 3320. And I don't know if it's visible. What? Okay. Owned by me. You see, all of these processes are running with the same primary access token. So I would conclude that all of those processes are in the logon session, right? Now, this process does not have the same primary access token, so this process is not within the logon session. Okay? It simply follows, because it doesn't have the same primary access token, it is not in the logon session. But it's interacting with the logon session. It's owned by the administrators group. But if I've gotten the wording right, finally, I don't. Okay. So this is the session that this token is representing, whatever that means. Alright. This is the one where it says identifies the session. The original wording was the session that this token represents, right? The logon session, the original wording for that bit from the help file was another insert. Actually, maybe what I can do is play this on mute, wherein I was attempting to sort of cut down on some of the extraneous time usage in the first video, where I couldn't seem to find that expression. And eventually I did find it. The mysterious expression that first made no sense, and then we thought it made sense, and then sense again. Is this one? This here, under the statistics part, specifies something assigned to the session the token represents. Okay. First, I'm going to say, now you see I've rebooted since then, so the numbers are all different now, but the idea is the same. Here's a fresh reboot, and now I have the logon times printed out. These top numbers tend to be different, and in fact, these two numbers represent logon sessions, two separate logon sessions. The help file, wherever that statement went, I've written it down somewhere in my notes, claimed that every process in a particular logon session will have the same primary access token. Somewhere here. Here it is. Now that's true of pretty much all the processes in this logon session. This logon session. However, when I print out the logon sessions, just print out the logon sessions that are active, or that may or may not be active. There are, in fact, both of these logon sessions exist and have existed since logon. They were created at the same time, it turns out. As you can see here, it doesn't. It's not fine-grained enough to tell me which one happened first, but in terms of the list, it appears as though the list is going in. Let's see now. Time is decreasing, right? So this is earlier than this, which would make sense. This would be the last session, logon session that was created. This is the first. This one happens to be dead. This was from terminal server session 1, which no longer exists. We're now on 2 here. So as far as logon sessions are concerned, there are just these two. And if the session, if by logon session they mean the same thing, they mean in terms of session, even though these may not be the actual keys, but they might be the public key part of the logon session. These are distinct. These are distinct sessions. This is in one session, and this is in another session. The session that is interacting with the desktop is the session. For instance, I have this little utility here thing, right? What it does is it sends a message, a hot WM hide, WM show window, or whatever to a window. And if I select this one, it promptly hides it and puts it in the system tray here. And I can bring it back. If I try to use that same program on this one, although I made a little icon here, the hide message was not received by this process and not processed. That doesn't mean that it's impossible for me to send a message to this process. I have another program which just takes the current session identifier. This one, well, this current process. What do I call it? To tray. Just made this the other day, which does put that one in here. But that to tray was launched within this session. If I run a notepad from here, okay, this thing will not be able to hide it. See? These are in separate. This is in a separate security context than this one is. I can run that little box, the little dialog box. No, system. Okay, now I've run this. This is within the this security context of these three. That should be able to hide the little notepad, and it does. Question is, would it be able to hide this one? And the answer is yes. So this this security context appears to include as a subset this other security context. It can communicate. There's communication from here to here, but there's no communication from here to here. So this thing can't send messages to this, but this can send messages to this. Now I don't know what that means in terms of this, like how has an insecurity, has this desktop now become insecure? Certainly a lower authority session, what was that called? That is, this session appears not to be able to send messages over to here, but this can be done in the other direction. So there is it seems unidirectional. Now whatever that means, I don't know. I'll have to think about that. But definitely there are two security contexts. There are two sessions going on. This may not be the key value itself that's used for it can't be, in fact, the key value that's used for encrypting and decrypting the messages. Nevertheless, conversations exist between these two. This might be the public key part. You know, I think that we mentioned public and private. So this value may be used to encrypt. But not that the decryption key is unknown, and this one has its own public encrypt public key if it is a session key, which I don't know how to prove or not. These are described as sessions when they're enumerated. The ones that have existed and have died never disappear from the list of what we call enumerate sessions. Is a function that this program calls. It's called enumerate logon sessions. Okay, so specifically logon sessions. This is a logon session, and this is its identifier. If it's a session key, is anybody's guess. It's an authentication identifier. That's about all you can say about it. As for key, the word key is not mentioned anywhere. Okay, now this is an insert, and I may just cut off the rest of the video from this point on and think a bit more about what I've learned. Okay, see you.